notes are over a review of congruent triangles, and let's first talk about the properties of congruent polygons. Triangles are congruent if they have the same size and shape. That means their corresponding parts, which are the corresponding sides, and angles are congruent. Corresponding parts are in the same position in triangles. Let's talk about CPCTC, which you're going to see over the next several lessons. It means corresponding parts of congruent triangles are congruent. You can use it in a proof. So if you know two triangles are congruent, you can use this CPCTC in a proof to justify pairs of congruent or corresponding parts. So that means, you'll have it in the reasons column. A congruency statement shows two polygons are congruent. So in this particular congruency statement, I state that triangle ABC is congruent to triangle DEF. Now, the order that each of these letters or vertices is written, it matters because the order of the vertices indicates the corresponding parts. So let's look at these two figures right here. And I was already given that triangle ABC is congruent to triangle DEF, right? And remember, the order matters. In this table right here, it shows the corresponding sides in the left column and the corresponding angles in the right column. So let's go through each of these. The first says that segment AB is congruent to segment DE. So right here, I've put some color to it. So segment AB, which has one tick mark, is congruent to segment DE, also shows one tick mark. That shows me that, or that tells me that those are congruent sides. But also, if I'm looking at this congruency statement, notice that A and B are in the first and second positions in the first half of the statement, and segment DE are also in the first and second positions in the second part of this statement. Let's move on to the next one. Segment BC is congruent to segment EF. Looking at my statement, B and C are in the second and third position. E and F are also in the second and third position. The next one, segment CA, is congruent to segment FD. Now I can see in the figure that they have the same number of tick marks, which shows me that it tells me that they are congruent segments. But also when I look at my congruency statement, segment CA, that's in the third and first position in the first half of the statement. FD is also in the third and first part or position in the second half of the statement. So you can see that order matters, right? Now let's look at the corresponding angles. I have angle A is congruent to angle D, first position, right? In both halves. Segment A is congruent to segment D. Angle A is congruent to angle D. Angle B is congruent to angle E. Notice that B and E are in the same position in each half of the statement. And angle C is congruent to angle F. C is in the third position, F is in the third position. So now let's try to write a different valid congruency statement. Let's just write this differently. If I call this triangle BCA, then what would the second half of my statement look like if I wanted it to be a valid congruency statement? So BCA, that's the second, third, and then first. Well, then the second half of that statement should be triangle EFD, right? So let's do our first example. We're going to complete this table that shows all the congruent angles and sides given the congruency statement that we already have. So we already are given that these two triangles are congruent. Now we're going to write down the corresponding sides and the corresponding angles. We're going to mark up the triangles. So we're going to put arcs and tick marks and everything all over it. And then we're going to write a different valid congruency statement. If you need to pause the video because I'm going too fast, rewind it, please feel free to do so. So we are given that triangle MNO is congruent to triangle BCD. Well, you see that M is in the first position in the first half and B is in the first position in the first half. So I know that angle M is congruent to angle B. The next one, angle N, would be congruent to angle C. They're in the second position. So I'm marking up these triangles and I'm writing the corresponding angles. Then angle O is congruent to angle D. O is in the third position, D is in the third position. Now let's look at our corresponding sides. The first thing I'm going to write is that segment MN is congruent to segment BC. M and N are in the first and second position. B and C are in the first and second position. The next pair of corresponding sides that we can write down is segment NO. Segment NO is congruent to segment CD. NO is in the second and third position. CD is in the second and third position. And then the last pair of corresponding sides would be segment MO is congruent to segment BD. MO is in the first and third position. BD is in the first and third position. So if we wanted to write a different valid congruency statement, we could write something like this. Triangle OMN is congruent to triangle DBC. So I just kind of switched the order, right? Instead of writing it MNO, I wrote what's in the third position, then the first, then the second. So I did the same thing on the second half. Let's move on. Now we're given the same type of problem, but I don't have triangles here for you to mark up or anything like that. We're just going to go off our congruency statement. We're going to determine all the pairs of corresponding sides and angles just from the congruency statement. So if we're given triangle QRS is congruent to triangle WXY, the first pair of corresponding sides I could write would be that segment QR is congruent to segment WX, right? QR is in the first and second position here. WX is in the first and second position here. The next pair could be segment RS is congruent to segment XY. And then the last pair of corresponding sides would be what? SQ, segment SQ is congruent to segment YW. Could I have written segment QS? Sure, you could do that. Okay, you just need the endpoints. Corresponding angles, angle Q is congruent to angle W, right? First position, first position. Angle R is congruent to angle X, and angle S is congruent to angle Y. And a different valid congruency statement could look like this. Triangle RSQ is congruent to triangle XYW, right? So I just changed the order, but I made sure that, for example, in this first statement, if R is in the second position here and I move it to the first, then X is in the second position here. Sorry about that. X is in the second position here and I move it to the first. Okay. So now let's move on and we're going to find missing measures in congruent triangles. In number 3, we are given that these two triangles are congruent, and our congruency statement tells us that triangle DEF is congruent to triangle GHJ. We're asked to find these missing angle measures and these missing side lengths. So first we know that angle D is congruent to angle G, right? Because they're both in the first positions. We know that angle E is congruent to angle H. They're both in the second position. And we know that angle F is congruent to angle J. They're both in the third position. That means the measure of angle E, which is congruent to angle H, is 52 degrees. The measure of angle G right here, well, it's congruent to angle D, that's 64 degrees. The measure of angle F, okay, well, what do we need to do to find the measure of angle F. I'm going to recall the triangle sum theorem, which states that angles in a triangle add up to 180 degrees. So we're going to have to do a little bit of algebra here. So I know the measure of angle F plus the measure of angle E plus the measure of angle D is 180 degrees. I'm going to substitute what I know into this equation. So the measure of angle E I know to be 52 degrees. The measure of angle D I know to be 64 degrees. Add 52 and 64, I get 116. Subtract 116 from both sides, and I get the measure of angle F is 64 degrees. This next little bit, the length of segment GH, right? So the length of GH is, well, I know that DE right here in the first and second position, I know it's going to be what's congruent to segment GH. So these two sides are congruent, which means their side lengths are the same. So if this is 10, this is also 10. What about the length of DF? Well, DF is down here, right? DF, first and third position, it's congruent to GJ. That's right here. These two lengths are congruent, which means this is also 6.2. And then EF, what would that be? EF is congruent to HJ, right? Or JH, which means these are both 10, okay? Have a side length of 10. Let's move on to example number 4. This is a pair of overlapping triangles, and I'm given that triangle ABC is congruent to triangle RST. Remember, order matters. So first, let's look at the measure of angle R. Well, angle R, it's in the first position here. Angle A is in the first position here. So these are my pair. This is my pair of corresponding angles. So if this is 90 degrees, then angle R is also 90 degrees, okay? Oh, and you know what? Okay, so I went ahead and I can write that there. I'll write that there in a second. I'm just going to highlight my pairs of corresponding angles. So angle A corresponds with angle R, right? Angle B corresponds with angle S. Angle C corresponds with angle T. So I just kind of added some color. So now I can write down that the measure of angle R is 90 degrees. Okay, so let's move on to the measure of angle T. Angle T, remember that corresponds right here. Well, and really it shouldn't be T, honestly, because this could be ATS. So I will get that changed. This should really be angle STC, right? Angle STC. So angle STC is what is 30 degrees, okay? Or I'm sorry, 37 degrees. Now let's move on to angle S. Angle S is up here, okay? It corresponds to angle B, and they are congruent angles, but I don't know what those angles are. So I'm going to have to use the triangle sum theorem. And I know that the measure of angle S plus the measure of angle R plus the measure of angle T, which should be STC right here, equals 180. So I know the measure of angle R is 90 degrees. Measure of angle, for all intents and purposes, this is STC, is 37 degrees. Add 90 plus 37 to get 127. I'm going to subtract 127 from both sides to get 53 degrees. So that means the measure of angle S is 53 degrees, right? So, and like in the past in middle school, you probably were just like 90 plus 37, 130 or 180 minus 127 is 53. Okay, right? When we write all of this out, this is just kind of like that upper level geometry way of like showing your work and justifying everything that goes into like finding your answer, right? Which is a big thing in geometry. So now let's find these missing side lengths. SR, right? Well, segment SR corresponds with segment AB, which means that's 6.5. ST, segment ST, well, right here, I'm given that this segment right here is 7.5, and this segment right here is 2. So segment ST is going to be 7.5 plus 2, which is 9.5. So we have to do that segment, use that segment addition postulate. Segment ST, the length of ST is 9.5, which means the length of BC, which corresponds to ST, is also 9.5. Okay, let's move on. Our last two examples are, we're going to use some algebra in these examples. So you see you are given a congruency statement. Triangle NOP is congruent to triangle WXP. We've got some algebraic expressions on here. We've got some side lengths and angle measures. And we are asked to find X, Y, and Z. So if I'm gonna find the value of X, what parts on here have the variable X in them? I see right here, angle W, right? Angle W right here is going to correspond with angle N, right? These two angles are the same, and I know angle N to be 90 degrees. So I know the measure of angle N is going to equal the measure of angle W. I know angle N is 90 degrees and angle W is 9x plus 18. So I write down this equation, and now I'm just going to solve for X. Subtract 18 from both sides. I get 72 equals 9x. Divide both sides by 9. I get that X equals 8. Now let's find the value of Y. Well, which expression contains Y? Angle O. Angle O corresponds with angle X. We know angle X to be 44 degrees. So I know these two angles are congruent. They're corresponding angles, and they are congruent. So that means their angle measures are the same. So measure of angle O equals the measure of angle X. I know the measure of angle O to be 7y minus 5, and angle X is 44 degrees. Now I'm just going to solve for Y. Add 5 to both sides. I get 7y equals 49. Divide both sides by 7, and I get y equals 7. Let's move on and find the value of Z. Z is actually shown as an expression that represents this side length. That segment, WP, corresponds with segment NP, right? WP, NP, same positions in my statement. Right here, we can see that these two lengths are the same. I've added my tick marks here. I've written that segment NP, or the length of NP, is equal to the length of WP. NP is 16, WP is 8Z. Now I'm just going to solve for Z. So divide both sides by 8, and I get Z equals 2. So let's move on to our last example. In this example, I do not have a picture, but it does help to draw a picture. We're given that triangle ABC is congruent to triangle FGH. So I just drew two triangles, right? ABC, FGH. I don't really care what this looks like, okay? If it's like entirely accurate as a picture. Sometimes just drawing a picture really helps you visualize, because this is kind of a lot of stuff here. So it doesn't have to be perfect. We're still asked to find X, Y, and then the measure of angle H. So I know that the measure of angle A is 36 degrees, and I know, and if I'm asked to find X, right here, that the measure of angle F is 7x plus 1. Well, angle A is 36 degrees, angle F is 7x plus 1. You can see angle A does correspond to angle F, which means those are congruent angles and their measures are equal. So I know the measure of angle F is congruent to the measure of is equal to the measure of angle A. Angle F is 7x plus 1. A is 36. And now I'm just going to solve for X. So I subtract 1 from both sides. I get 7x equals 35. Divide both sides by 7, and I get X equals 5. Next, we want to find the value of Y. I can see right here are the two expressions that contain y. BC is y plus 3, that's right here, and GH is 2y minus 1. Those are congruent sides, which means their side lengths are the same. So the length of BC is equal to the length of GH. BC is y plus 3, GH is 2y minus 1. I need to move my variables to one side and my constants to the other. So I subtract both sides, y from both sides. I get 3 equals y minus 1. I'm going to add 1 to both sides, and I get y equals 4. And lastly, we need to find the measure of angle H. Angle H right here. Well, I know the measure of angle G to be 62 degrees, right? And I'm looking to find the measure of angle H. I know F to be 36 degrees, right? So this is 36 degrees. This is 62 degrees. We're asked to find the measure of angle H. So I am going to use my triangle sum theorem, which states that the measure of angle H plus the measure of angle F plus the measure of angle G is 180 degrees. And then I fill in what I know. Angle F is 36 degrees. Angle G is 62 degrees. I'm looking to find the measure of angle H. 36 plus 62 is 98. Subtract 98 from both sides, and I get the measure of angle H equals 82 degrees. And that concludes your notes over a congruent triangles review. I hope it was helpful.